So with our big ideas, it opens up a question like this. P negative 1, negative 4 is a terminal point of angle theta in standard position. Determine the exact values of the 6 trig ratios for theta. So if I draw a picture of what's happening here, there's the point negative 1, negative 4. Apparently, it's on the terminal arm. There's my terminal arm of an angle in standard position. Standard position starts on the positive x-axis. Here's the angle theta. And apparently, that's enough information for us to figure out sine of theta, cos of theta, tan of theta, as well as cosecant theta, secant theta, and cotangent theta. All of this without our calculator. Well, we're doing trigonometry, and this may be surprising, may not, but a very key strategy for doing trigonometry is to draw a triangle. Yeah? Okay? So much of a strategy that I even call these questions, this is a triangle question. It's a triangle question because your best way to solve it is to draw a triangle. Now, the triangle that we're going to draw is always going to be a triangle that connects the angle we're thinking about to its reference angle. We already talked about the importance of reference angle and the definition of reference angle. Here, that scribble, I'll rewrite it nice. Theta r. There we go. You still see it? That's our reference angle right in there. Remember, our reference angle is always the angle between the terminal arm and the nearest x-axis. And with that reference angle, we've got a triangle. You are also going to get so good at a squared plus b squared equals c squared this year. First of all, can you tell that on this triangle, this length is 1? This length is 4. And even though you had to write this out in grade 9, now that you're in grade 12, you're just going to go a squared plus b squared equals c squared and say, I know that that's equal to the square root of 17. How's your mental math worked out okay there? 4 squared, 16, 1 squared, 1. 16 plus 1 is 17. That would be c squared, so it's square root of 17. Now, the power of our reference angle, it's a right angle triangle. Do you know what sine of your reference angle is? Yes, sine is opposite over hypotenuse. If I think about my reference angle, I would say sine of my reference angle is 4 over root 17. But then if I want to find sine of my actual angle, it's also going to equal 4 over root 17. But according to our cast rule, our actual angle's in quadrant 3. And sine in quadrant 3 is negative. So our reference angle tells us that sine has to be 4 over root 17. And our cast rule says since it's in quadrant 3, it has to be negative. I have some good news. Well, you know how in grade 11, if you have a square root in your denominator, you had to rationalize your denominator? And a question was considered not simplified if you had a square root in the bottom, and you'd lose a half mark for not simplifying? In grade 12, they assumed that you did a really good job of learning that in grade 11. So much that they're like, we know you know how to do it, So it's okay if you don't do it. You can leave your answer with square roots on the bottom in grade 12. You have to be careful. They still check to make sure you know how to do it because they'll have a multiple choice question. And they'll write the answer as -4 root 17 over 17 and say, do you remember how to rationalize the denominator? Because we did that in our answer key. But if you are just asked to write your answer, you're allowed to leave it like this. Isn't that nice? Other things in grade 12 where you would have lost marks in grade 9 or grade 10? Let's say you do all your work and you get your final answer is 10 over 8. What did you have to do in grade 9, 11, 10? Simplify. In grade 12, they assume you know how to simplify. And so you can leave your answer as 10 over 8 and get full marks. Of course, in multiple choice, it will be simplified. But for regular answers, you don't have to simplify. You could even write, instead of 10 over 8, if you wanted to, 10,000 over 8,000. Still the same thing, but not simplified. And we'll see a reason why that is in a second. Cos. Cos of theta, well, we know cos is adjacent over hypotenuse. According to our reference angle, adjacent over hypotenuse is 1 over root 17. According to our cast rule, it should be negative. Tan of theta, opposite over adjacent. The opposite is 4, the adjacent is 1. So we could write this as 4 over 1. You could write it just as 4 as well. That would be fine. According to our cast rule, tan is positive in quadrant 3. So if you forget about the cast rule and just write the numbers, you will get 1 right and 2 wrong every single time. So the cast rule is important. Oh, no, if it's in quadrant 1, you'll get them all right. But it's still good to know the cast rule. And now we get to our reciprocal functions. And if we think about what a reciprocal means for a fraction, that's flipping a fraction. You could, okay, first of all, I'm going to do it the long way so that you can see how it works. Okay, the definition of cosecant theta is equal to 1 over sine of theta. It's the reciprocal. And if I know that sine of theta is -4 over root 17, I would have 1 over -4 over root 17. How do you divide by a fraction? Right? If I have two fractions, I can even make this 1 over 1 divided by -4 over root 17. How do you divide by a fraction? You need to multiply by the reciprocal. If I multiplied by the reciprocal, I'd have 1 over 1 multiplied by root 17 over -4. That math is pretty easy, multiplying by 1. We get, as our final answer, -root 17 over 4. You can do this if you want every single time for the reciprocal trig function. Okay? I'm going to show you a shortcut right now and see if you can follow. Cos of theta is -1 over root 17. Secant of theta is -root 17 over 1. Do you think you could follow that shortcut? Do you think for tan you're able to do this without doing all that work? It's the reciprocal. So what happens to the answer? That fraction just becomes the reciprocal. We can see why in the green with the definition of what's happening. But we can, and we will, just do it quickly just by flipping the answer. Okay. Again, I'll give you the question for this, 8. But I'm going to do the last example right away